29. Blocks A and B of masses 1.0 kilograms and 2.5 kilograms, respectively, are on a horizontal surface and in contact with a circular vertical wall. The vertical wall makes a circle of radius of 1.25 meters. Both blocks are also in contact with each other as shown in the top view. The horizontal surface has negligible friction, whereas the coefficient of kinetic friction between the vertical wall and the blocks is 0.20. A force of constant magnitude F is being exerted on block A such that both blocks move around the circular wall. The direction of the force is constantly changing such that it is directed tangent to the circular wall. If the blocks move at constant speed, and it takes them 10 seconds to go once around the circle, the magnitude of F is most nearly. First, we must consider the nature of the force that is being exerted here. In the first place, if you consider that this object is moving with constant speed, then we must acknowledge that instantaneously the applied force F and the friction force must be canceling each other out, because if it were otherwise, you will have a tangential acceleration and the object wouldn't have a constant speed. Therefore, the only force that makes up the centripetal or net force on the object is the normal force exerted by the wall. So, we can use the speed, which is 2 pi times the radius divided by the period, to get to the centripetal acceleration. Now this is equal to 2 pi times 5/4 meters divided by 10 seconds. And that's equal to pi over 4 meters per second. So that's your speed. Your centripetal acceleration then, which is the speed squared divided by the radius, is equal to pi squared over 16 times 5/4 of meters. And so, this is going to give you pi squared over 20 meters per second squared. Given that your normal force, as we said before, is your centripetal force, and that's equal, according to Newton's second law, to mass times centripetal acceleration. And that is equal to approximately 1.727 newtons. Now the friction force then is equal to mu k times the normal force. That's 0.2 times this value, and that's approximately 0.35 newtons. We said before that the friction force and the applied force must have equal magnitude for this object to have a constant speed, and so this force has to have a magnitude of 0.35 newtons, which is option C.